I'm gonna show you how to implement Gaussian Elimination method by using the PyTorch library. So in the end, you'll have a cool application on the internet where you can go and enter values like this, and then press calculate, and instantly you'll know how to solve it. The Gaussian elimination method is something that you can use to solve an equation like x plus 2y equals 3, 4x plus 5y equals 6. This is a method that you can use so that you can get what x and y equals. So you can write it out as 1, 2, 3, 4, 5, 6. You want it to be in the format 1, 0, 0, 1, and this is your pivot row right here. You want these to be 1s. So you'll start by, the first step is it checks the pivot rows. So this one is already a 1, so it doesn't need to do anything. But this one, it's a 5, so it needs to divide row 2 divided by 5, or factor. So then it'll get 4/5, 1, and 6/5 over 1, 2, 3. Next, since the pivot rows are good, it needs to get rid of this 4/5. So to do that, it'll multiply row 1 by 4/5, and then subtract row 2. And row 1 stays the same because this is a row operation. So row 1 is still 1, 2, 3. But then you multiply 4/5 times 1 and subtract 4/5, so you get 0, which is what you want. And then you'll get 2 times 4/5 minus 1, which would be 3/5, and then multiply 3 times 4/5 and subtract it from 6/5, and you get 12/5 minus 6/5 is 6/5. So now, programmatically, you look through, it does the loop again, and it sees that these pivot rows do not equal 1. So it's going to go through again, and it's going to go and it's going to divide row 2 by 3/5, or factor out the 3/5. So you'll get 0, 1, here I'll write it down, row 2 divided by 3/5. So you get 0, 1, 2, and then on the top you have 1, 2, 3. Now it's going to go through and see that you want a 2 here. You want to factor out this 2. So to do that, it's going to do row 1 minus 2 row 2. And then it'll get 1, because 0 times 2 is 0. 0, 2 times 1 is 2, minus 2 is 0. And then it'll get 2 times 2 is 4, 3 minus 4 is negative 1. And then the bottom will stay the same, and then you're done. And that's using the algorithm. So now you have x equals negative 1, y equals 2. And then you can see, we can double check with our program we made, and that shows that that's true. Hey guys, welcome to the coding part of this tutorial on how to code Gaussian Elimination method using PyTorch and Streamlit. In this tutorial, we'll be using PyTorch, which is a popular deep learning framework, and Streamlit, which is a fantastic library that makes it easier to create interactive web apps like this one right here. And I'll show you how fast it works. You just press calculate and it automatically does the Gaussian elimination for you for this matrix, and then you can just change things and it'll create new results for you. So the first thing you want to do is import the libraries, which is Streamlit and Torch, and then we're gonna create a header for the web app like this, and then to test it out and to see it running, we can do Streamlit run, and this will run it right on Streamlit run new app.py, and cd into linear dash algebra. There. Now we can see it right here running. So then now let's ask the user for a matrix by size by writing two numbers, one for the column and one for the row. So we'll do this. See, st.write is what displays stuff, and then if you want a number input, you do st.number input, and st is short for Streamlit. And then we can just say always run the changes. So now it's asking for a 2x3 matrix. If you want it to be bigger, like a 3x4, that would be an x, y, and a z, and then increase the columns as well, because then it would be 3x3 plus the b column, which makes it 4. So we'll use the number input function from Streamlit to get the number of rows and columns for the matrix from the user. We'll next create a matrix using PyTorch, that is the number of rows by the number of columns, and allow the user to input values for each element in the matrix. So we'll use a nested loop to go through each row and column of the matrix and use Streamlit number input function to get the values from the user. The F, please enter the value for row I plus 1 and column J plus 1 part creates a string that displays which row and column the user is currently inputting the values for, so you're not just randomly inputting the values. And so now we'll add a calculate button so the user can start the Gaussian elimination function. So then they can press calculate. And this is just the matrix, so that displays the matrix so they can see what's happening. So I just entered some random values so you can see what it looks like. Put a negative in this one. Oh, because it shrunk because I put it to 2x3 and it was still 3x4. So now you can see it's 1, 1, 1, 1. Change this. Press calculate. 3, 1, 1, 1, 1. So now that we create a button so that whenever we press calculate, it does it. And then we'll create a function and assign it to the variable calculate So if the button is clicked, then the Gaussian elimination method will start and the augmented matrix will be displayed. So now we'll get into the code for the Gaussian elimination method, which is just doing what we just did by hand, by code. The goal is to convert a matrix into an upper triangle matrix so that it is easy to solve the linear equations that the matrix represents. So first we'll define the matrix, and we want it to be an augmented matrix. So we'll go and now we'll get the size of the matrix, because that's important to keep track of throughout doing the calculations. Now we'll use the size function from PyTorch to get the size and assign it to the variable size. The width equals the number of columns, and the length is the number of rows. So next we create a loop that starts with 0 and goes until the number of rows, and name it k. The purpose of this loop is to manipulate the values in the matrix to eventually get the result we want. Within this loop, we use the function torch argmax to find the row with the maximum value in the column k. This row will be used as our pivot row. To ensure that this pivot row is used, we swap the current row with the row containing the maximum value using the code augj, max index equals augmax index, k. We then check if the pivot row is equal to 0. If it is, we use a function stWarning to output a message warning, a warning message saying pivot is 0, cannot proceed with Gaussian elimination, and then break out of the loop. This is because if the pivot is 0, it means we cannot divide by it, so then we can't process with Gaussian elimination because it cannot be processed. If the pivot row is not 0, we can divide by the current row, but we can divide the current row by the pivot row using code augk equals aug of k divided by aug of k, k. This will make it so that the pivot is equal to 1. So I'm just going to start with the loop up to that point. Enter. So for what I just said, that's the code for what I just said. But for k in range length, so if it was bigger than 3, then it would continue. So then after that, finally we use another loop. I'm going to show you the loop first, actually. So here's the other loop we use right here. Finally, we use another loop to subtract the current row from all the other rows to get zeros in the lower triangle. The process of this is to eventually get an identity matrix on the left side and the result on the right side of the augmented matrix. After the loop's finished, we use st.write to display the final output. So I'm going to show that. And that's within that first loop. And then three, two, one, 1, 2, 3, and then press calculate. And it says it's -1, 2 for 3, 2, 1, 1, 2, 3. For 3, 2, 1, 1, 2, 4. And then think of this row as like right underneath this row, not side by side. It's just this is how computers display it. So then, now that you have your own matrix calculator, you can upgrade the size of the matrix and input values. I'm going to put a big value in here, 109, 25, 23, 25, 17, 7, 8, 3, 36. I'm just putting random numbers in. And then instant. And that's for a 5x6 matrix, 5x5 matrix with a B column. And then, so this would be, let me think, A, B, C, D, E, F. So that's, E. So 1, 2, 3, 4, 5 variables. And I think it solves them very quickly because of the PyTorch. It only uses 2 libraries. So thank you, and I hope you enjoyed this and learned Gaussian elimination.